Welcome to Equinox, where Rob and I are striking the balance between the light and the dark. This is episode 51. My name is Joseph Darnell, and I'm joined by the doctor with today's forecast, Robert Carter. Hello, Rob.
Hey, Joe.
I thought it would be appropriate to introduce the subject with the weather, because we're talking about meteorology.
I like that, but I was still giggling because we were just singing the Phineas and Ferb theme song.
Yes. If you want to pay for the bootleg version of this episode, you can hear Dr. Robert Carter sing the theme.
No. We're not going to do that, but I'm still laughing about it. So
not for the right price?
No. Nope.
Oh, snap peas.
Hey, I saw they've got all these different ways of judging your personality.
Yeah.
Well, I saw one with the ISTJs, INTP sort of thing.
Yeah.
Or whatever that's called. But it had all the
Myers-Briggs.
Yeah, Myers-Briggs with all the characters from Phineas and Ferb.
Oh, cool.
And it was brilliant. He's like, yes, that person is definitely Doofenshmirtz. And well, I'm Ferb. Yeah, I'm definitely Ferb.
Yeah, as a kid. Spot on. I can see it.
Anyway.
Now, if you were using the Enneagram and you were looking at Marvel movies, I saw this earlier today. I think that you would be the Type 7, and that means you would be, what's his name?
I don't know.
Star-Lord. You would be like Star-Lord.
Oh, I'd like that.
Yeah.
Anyway, sir. I can't be Groot.
Yes. Can you be Groot? Everybody should be Groot. I am Groot.
Oh, boy.
Speaking of which, with the weather changing these days, I've been dying, Rob. I felt really gross. We've already talked about pollen and allergies. And, I don't want to wallow in misery anymore. My only savior, my only hope is the weather change. I've been thinking about this so much because every time there's a thunder shower and a rainstorm that blows through, we get a little relief from the pollen. But I was telling you before that I sound I sound really bad, but I sounded worse last week. I just couldn't record. And we were also taking family vacations, so that wasn't any fun. I was sick in bed for a day of, our vacation time.
Terrible. It's happened to me also.
Now, how are you faring? Are you doing okay with the allergies?
Yeah, I don't get very bad allergies.
Oh, good.
Little scratchy eyes and sometimes a yucky throat, but that's no big deal.
Oh, wow. That's amazing.
Plus, the weather has been so odd anyway. This is the most bizarre spring. I mean, it was warmer in February than it is. We said that last recording also. But right now, it's the middle of February. One of my friends up north is saying it's going to snow tomorrow.
Right.
Someone on Facebook just posted snow pictures. And here it's cold and gray and, 50, maybe 60 degrees today. And I'm trying to raise bees, and I'm like, come on, where's my hot weather? And it's just very odd. Everything's weird.
I went out and checked on the girls. We'll talk about them later on the show.
Okay.
But they're doing fine, and I give them some more sugar water using Dr. Robert's recipe.
We can't talk about them now. We got to wait.
We'll get to that later in the show.
All right.
So everybody knows we didn't want this to turn into the bee podcast. So we'll talk about bees, but we'll save that for after our main topics. Anytime we do want to bring out the bees and give you the latest stories. Yeah, just right now, all I want to complain about is how my throat hurts. Then we can talk about the weather, meteorology. Rob, explain the weather to us. It's killing me. One of my favorite subjects in school was science, and it was actually kind of boring when we got to meteorology to me. I thought it was boring, but it also was very interesting how much we understand and how far it's come along. And I'm actually very curious about things this time of year, because one thing that wasn't explained, I don't know if anybody has a great explanation. This is the prelude to the weather, is how when the southern and the northern hemispheres flip-flop.
Yeah.
Because we've got summer when they've got winter and vice versa. Nobody told me that when I was a kid. I had to stumble across that information. And then it was weirder that here in North America, we're actually furthest from the sun, according to people who've told me such things, during the summertime, when it's the hottest. And you just assume that if it's summer, it's hotter because you're closer to the sun. So I would love to hear your explanations for these sort of things. Do you have any friends that are meteorologists?
Actually, someone related to me in my marriage is an official National Weather Service meteorologist.
Interesting.
And I knew him as a child. Anytime I was in college and he was like, 8 or something, 10, 12. But he always knew what the weather was that day. So he grew up to do what he loves.
Were you ever tempted by the meteorology career path?
No. And then when I got into graduate school, I went to the Rosenstiel School of Marine and Atmospheric Science at the University of Miami. So I literally went to graduate school and got my PhD alongside today's climatologists. The people I was going to school with, they're now running,
the networks,
big national government laboratories and stuff. Yeah, predicting hurricanes and failing and stuff like that.
I worked with a nice guy who used to work for the Weather Channel. He was one of their web developers. Very nice guy.
Well, okay, let me ask you a question. I remember listening to Rush Limbaugh back in the 80s or 90s or whenever he started. This is when the global warming thing was just starting, and he just railing that you can't predict the weather next year. So, you can't even predict it next week. How can you do it 100 years in the future? And remember, even back then, before I had more knowledge on environmental and atmospheric stuff, like, dude, no, you can predict the weather. Hey, Joe, what's the weather going to be like 6 months from now?
I don't know. Well, in a general terms, 6 months from now would be fall.
Yeah, it'll be fall. It'll be
going to be fall weather.
Yeah, okay. And if it's in the summertime, you know what it's going to be like about 6 months later in the wintertime.
Right. Cold and drab.
You can predict the weather within reason over long periods of time. You can predict this time next year, it's going to be probably in the middle of the day in April of 2022 in Georgia. It'll be between, 60 and 80 degrees. I would be shocked if it was 90, and I would be shocked if it was 30 in April. So I can put limits on my predictions, and I can put statistical parameters on my predictions.
Yeah.
And you can, in fact, this is really funny. Do you know the best predictor of tomorrow's weather? Of any day of the year. Pick any day ever in your entire life. The best predictor of the next day's weather.
Or broken bones?
No.
The record of what the weather was a year ago that day?
No. So the best predictor of tomorrow's weather is today's weather. Because the variability from one day to the next isn't really that much seasonally. And if you want to put money on it, you say tomorrow's going to be like today. And every once in a while, a warm front or cold front will blow through and the weather will change a lot. But there's very small variation from one day to the next, very large variation from one season to the next, very little variation from 1 year to the next. So we have different types of things that are affecting the weather, and they operate at different scales. Seasonally, we can understand the sun. But what about over a century or a millennium? That's hard. But because we can understand the primary forcing functions of the weather, we can make predictions very far out. We can say this is going to get drier, this is going to get wetter, this is going to get warmer, this will get colder. The thing is, you can sometimes make a global prediction, but applying that to a local area is extremely difficult. Because if you make a global change, you might affect wind, major weather patterns across the world. But the wind patterns are going to change, and the wind is going to drive local environment more than anything else. So let me ask you, What is the single greatest driver of weather? Weather equals temperature, rainfall, the amount of sunlight, breezes. What's the one thing that drives most of the weather in the world?
I would assume it would have been something like the push and pull of the moon. Gravitational force.
Interesting.
But then, it seems kind of silly to say that because are we taking for granted the sunlight and its energy?
You just did, but I'm not.
Because that would be the number one.
Yeah, that is number one. Okay. Yes, absolutely.
Because I was taking it for granted because it seems so obvious. I thought you were going to say something. It's like, it's actually the Arctic Circle. How much ice is melting and refreezing.
That does have an effect, honestly, but no.
Warm ice water versus cold ice water.
The single biggest effect on weather is the sun.
Okay. Yeah, I'm glad I knew that. All right.
The second biggest effect is the fact that the Earth spins. Putting those two things together makes for some already very complicated weather patterns. So what areas of the world get the most rain? You think, tropical rainforests, right? The equator.
Yeah.
Right? The equator. Things that are on the equator tend to be really wet. Why is that?
Well, more humidity, condensation, all of it going up into the atmosphere, come back down again because of the heat.
Exactly. But why is it about 30 degrees north or 30 degrees south of the equator are all the world's major deserts?
Oh. Yeah, rather than, say, much closer to an ice cap, you're thinking.
Yeah, or why isn't it the deserts? Why are the deserts not in the hottest places, which would be the equator? They're in about 30 degrees north or south. Wait a minute. What is going on here?
Yeah.
Well, what's happening is that our first major weather pattern, and this affects worldwide weather. Think of sunlight intensity at the equator. It's at its maximum.
Right.
Because the sun is directly 90 degrees above you. Therefore, you're getting the full force of the sun. When you're at the North Pole, the sun's actually shining from the side, and the sunlight stretches out. It's spread out over a greater area, so the sun intensity is less the further north or south you go from the equator. But because the maximum sunlight's at the equator, maximum heat is at the equator, maximum evaporation is at the equator, and because warm air rises compared to cold air across the entire equatorial belt of the world is a giant low pressure system where the air is rising. But the thing is that rising air gets colder. And so all that water that gets evaporated goes up in the air and then falls back down again as rain.
Yeah, that makes sense.
And so that describes right there the equatorial regions of the world and why it's so wet there. But if that rain falls out of the sky, that means the air doesn't have as much moisture. And rising air, it has to go somewhere. So it rises up, and then when it gets to a high altitude, it flows north and south. And eventually it comes down again. And when it comes down, it's extremely dry. And it comes down at about 30 degrees north and south. So we have the Sahara Desert. We have Iran and Iraq. We have the Gobi Desert. We have Arizona. Those are all the same latitude. Likewise, in the southern hemisphere, you have Australia, places like that. It's dry there. So this is called a Hadley Cell. The first biggest thing that's driving world weather is sunlight, warming air at the equator, lifting it up, and it dries out, and it comes down at about 30 degrees north.
I was not expecting that, but it makes a lot of sense.
Okay.
So if the Earth was a degree or two farther away from the sun, would this relocate the deserts around the... Okay.
No, but it would change the intensity of it.
Okay.
If you move the Earth away, it gets a little cooler, there's less sunlight, there's less energy to do this lifting and evaporation and moving, but it would be the same scale. All right? Now let's throw in a curveball. Literally, a curveball.
Ooh.
The Earth is spinning.
Yeah.
And because of the spin of the Earth, and because a point at the equator is literally moving at 1,000 miles an hour, you have to move at 1,000 miles an hour at the equator to get all the way around one circle in one day, because the Earth's about 24,000 miles in diameter, in circumference. But at the North Pole, particles are hardly moving at all. They have to move. If you're 1 foot away from the North Pole and you put a mark in the ground, it has to go in a circle that only has a 1 foot radius. It has to move in that length in 24 hours. I mean, that's way. It's only I don't know, a millimeter an hour or something like that, or not? It's not a couple inches an hour, rather than 1,000 miles an hour. And that difference right there means that if you want to go from the north to the south or the south to the north, you have to change your angular trajectory considerably. But air doesn't know that. And if it's flowing, so we just described air going up at high altitude, moving north and south, coming back down again, well, then it's going to come back toward the equator. Along the surface, is from the deserts, it's going to flow, let's say from the Sahara Desert, it's going to flow southward across Africa until it gets to the equatorial region and rise again. But if you're moving across the surface, you have to turn to the right in the northern hemisphere. And it's a pretty significant thing. And so this affects, that right there, that Hadley Cell combined with the Coriolis force, that affected the European exploration of the New World.
Oh, of course.
Why did Columbus sail south to cross the ocean?
Less storms?
No. All the storms are down there. All the hurricanes on the equatorial hurricane belt just north of the equator. He sailed south from Spain to catch the trade winds that are caused by the descending air flowing south to the equator and curving to the right. And since they're moving south, if you turn to the right, the arrow is pointing at the New World.
Yeah. Huh.
So he said from Spain or Portugal, he sailed south along the African coast and then turned right and followed the wind all the way to the New World. And on the way home, he didn't come back that way because he would have been fighting the prevailing winds the whole time. He went north. He made a circle because north of when you get north of Georgia, the prevailing winds are offshore toward Europe. And so you can actually float in a circle. In fact, there's a giant gyre in the middle of the Atlantic Ocean, the North Atlantic, where the winds and the current goes in a circle. But in between, we have these lovely trade winds driving toward the west. And north off the coast of like New England, the winds are driving toward the east, the easterlies. But in between, we have what's called the horse latitudes, or the doldrums. Basically, the latitude of the Georgia coast is hot, it's sultry in the summertime. If you ever go to Orlando in the summertime, ugh,
Yeah.
misery.
Yeah.
There's no wind. Ugh. That's because you're not far enough south. If you go to Miami, I lived in Miami for 9 years. For 7 of those years, I literally lived on the coast.
Oof.
It was never more than 92 degrees. That was the hottest temperature. I looked at the temperatures about every day. I was at the Rosenstiel School of Marine Atmospheric Science. Everyone was aware of the weather. Hottest temperature ever in 9 years. 92 degrees. Even though it was that far south. It's because there was always a breeze. And the breeze was always blowing in off the ocean. That's the breeze that carried Columbus to the New World.
Oh.
Now, you move just a few miles inland in Florida, down that far south, and you lose that breeze. It's still maybe a little bit, but it's not nearly like it is on the coast, and it is awfully hot. When I was in Belize, I spent two-week trips down to Belize 2 summers in a row. We spent a week in a rainforest and a week on the coral reef on an island about 20 miles off the coast. And it was right there in the area of the trade winds, but you get far enough inland, and the winds are not steady. And when the winds stop, I mean, it was enough to kill this white boy. I literally, one particular time we're walking down a road, and I was so dizzy because I was so hot, and I got so dehydrated so fast. I'd never felt anything like that, growing up in New York, even living in Georgia. This is before Miami. I'd never experienced anything that hot. But out on the coast, on that island, I mean, it was cool. It was breezy. The wind never stopped blowing, except one day out of the 2 weeks I spent on this little island. One day the wind stopped blowing and it got hot, and I must have lost a quart of blood from mosquitoes. But I never got any mosquito bites at any other time on that island because the wind was always blowing.
Huh.
So we're talking about these massive and important circulation patterns. Here in Georgia,
Yeah.
where does the weather come from?
Well, it would be coming off of the Atlantic.
No, what direction do all the storm fronts come from?
Northwesterly direction?
Northwesterly or westerly?
Yeah. It just seems kind of oxymoronic because the direction we're traveling is always, we're going east. So, being so close to the ocean, I'm aware of when we do have hurricanes in Georgia, we do pick up their storms and the like.
Yeah.
But you're not wrong about the weather patterns in general.
But the weather patterns, when you look at the front, it's almost always angled.
Yeah.
From the southwest to the northeast. It's about a 45-degree line, and the wind is blowing along that line. Almost always. And the weather comes from Alabama, which then comes from Mississippi. Here, most of the major weather patterns, not always, but most of the time, it's blowing from the west toward the east at an angle going a little bit north. And it's because we're just north of the doldrums, and the major weather pattern now was blowing in that direction. Go down to Miami, the wind is almost always blowing from the east. Here, it's almost always blowing from the west. Now, wait a second. 30 degrees north is all the major deserts in the world. We're at 30 degrees north. Where are our deserts? How come Georgia's not a desert?
We're so close to the coast.
Nope.
We have a coast?
Which coast? Which way does the weather come from? It doesn't come from the Atlantic. It comes from
the west, yeah.
The Gulf of Mexico.
Oh, okay.
There's a giant pool of water that our prevailing winds blow across, and they pick up moisture and dump it on the south. If the Gulf of Mexico wasn't there, if that was land, we would be Arizona-like. We'd be so dry and desert-like.
Oh,
that's cool.
That's convenient.
Oh yeah, it's wonderful.
Yeah.
It totally changes everything, but it changes on, thousands of square miles are different in the world because there's this water body there. If that was land, there would be no moisture and we'd be a desert.
So that benefits everything up and down the Gulf of Mexico?
On the north and the east.
Gotcha.
You go down to the south and the west, you get the Yucatan Peninsula. Just compare Florida to Mexico. Florida's really wet. Mexico is really not. They're at the same latitude. Or a lot of parts of them at the same latitude anyway. All right, enough of the Hadley cells. Let's talk about...
By the way, before we move on then, on the Hadley cells, did you mention where the name came from? I'm assuming it was some meteorologist, Bernard Hadley of, 1872 or...
And the cell north and south of those are called the Ferrel cells. So yeah, these are people's names. Okay, ocean currents. I put in the notes a map of the major ocean currents. This is really cool. This affects world climate. Because you have warm water and cold water, and because you have prevailing winds, the winds move the water, but they move it in weird ways. Because if a wind is blowing across water, well, water is going to curve in the northern hemisphere to the right and the southern hemisphere to the left. The water doesn't flow in the same direction of the wind. It only kind of flows in the same direction of the wind. And when you have lots of rainfall and things like that, it changes the surface of the water, so the water actually has to flow downhill, strangely.
Yeah.
Even though you think the ocean surface is flat, it's not flat. And the prevailing winds, they pull water downwind. And the water has to return somehow. So usually like the prevailing wind blows into the Gulf of Mexico, into the Caribbean Sea. Well, it comes out again as the Gulf Stream. And so you have this massive flow of very warm water from the Gulf of Mexico and the Caribbean Sea, whatever you want to call it. And it flows north along the Atlantic coast of North America. And then it takes a right-hand turn and it crosses the ocean. You ever describe Ireland? What's the first thing you think of when you think of Ireland?
Green.
Green! What? Do you know what latitude Ireland is?
No.
The same latitude as southern Norway. Is just south of the southern tip of Greenland. It's at the latitude of Hudson Bay. Arctic Canada and Ireland, or Siberia and Ireland, are at the same latitudes. Why is Ireland not frozen? Why is it cloudy and rainy and warmish there?
Because it's really close to the Gulf of Mexico?
No, it is. It's downstream of the Gulf of Mexico. The Gulf Stream brings warm water across in a northerly direction and impinges upon Ireland. Iceland also gets a part of that benefit, but not all the time. The Gulf Stream flows into the Arctic Ocean. That means the Arctic Ocean is a lot warmer than it should be because a massive amount of heat is pumped into that ocean from the Gulf of Mexico, and it affects the climate of Western Europe and Eastern North America. There's a whole lot of really interesting oceanic currents. The Kuroshio Current comes north out of the South Pacific Islands, and it hits Japan. So Japan has a lot more of an equable climate. It's a lot more pleasant living in Japan than it should be, considering how far north it is. But there's this thing called the Antarctic Circumpolar Current. Think of Antarctica. It's not connected to any other landmass, right?
No.
Well, that means that the wind has nothing to stop it. And the wind just north of the whole coast of Antarctica is blowing to the east. And that means that it's the roaring 40s, they call it. I mean, it's the worst weather in the world. Horrible winds, huge waves, a strong current, and it's always going toward the east. And the water just circles the globe. And the wind just circles the globe. But what that does, it cuts off Antarctica from the rest of the world. There's no major ocean currents that penetrate that to bring warm water to Antarctica. And this is why Antarctica, or the Antarctic, is a lot colder than the Arctic. They get the same amount of sunlight. They just don't get the same amount of heat from ocean currents. Or consider the Galapagos Islands. I've been to the Galapagos Islands. Really awesome place, but the water's freezing cold. It's on the equator, and the water is cold. What? It's something called the Peru Current. It flows north from the Antarctic Circumpolar Current. It flows northwards across or along the western coast of South America and goes all the way up to the equator. Same thing is true in North America. You go like all the surfers in California, right? Yeah, you can be a surfer. They're all wearing wetsuits because the water's cold. Why is it cold? Because the prevailing current is coming down from Alaska. And that cold water comes all the way down the coast. And so we're talking about these humongous circulation patterns that are affecting the temperature, and the temperature affects the weather.
So in general, is it just windier across the ocean because there's no trees, there's no hills?
Yes.
Because I noticed in general when we were on the beach that it does seem to be windier in general.
Oh, yes.
The trees, the forestation slows things down. Mountains probably slow things down.
Yes, and those are all in notes.
Okay.
So let's talk about wind first. There's a link in the notes. I want you to click on the link. earth.nullschool.net.
Null School. Clicking now. Loading page. Oh, this is cool.
Oh, this is one of the coolest things ever.
It's a globe and you can click and drag it to rotate it with your mouse.
It is a real-time map of current winds on the Earth.
Very well designed.
Oh, yes. Go over toward the Philippines. Do you see that tight little red circle?
Yes.
That's a cyclone. Now, during hurricane season, there'll be many of them, but that is the windiest place on the Earth right now, is that spot just to the east of the Philippines.
And you can see that the current picks up speed in its circular motion right there.
Yep. Look at Antarctica.
It's got a little activity.
Can you see everything going clockwise around Antarctica?
No, there's fluid. There's a
it
good
breaks
chunk
up a little
of it
bit.
That does.
Well,
yeah.
Anytime you have fluid flowing, like the air is a fluid, if it starts to oscillate, you can get circles that spin off, gyres that spin off. But in general, you can see the circulation around Antarctica, and there's one place where it's making a circle within a circle down in the south.
Yeah.
Yeah, well, that's just a gyre that popped out, but the current is going around Antarctica.
This is awesome.
If you look at India and Africa, there's not much wind across that entire half of the world.
No.
It's not monsoon season. The altitude of the Tibetan Plateau drives major weather patterns. If the Himalaya mountains weren't there, the weather in that whole section of the world would be completely different. But because of the altitude of those mountains, you get this oscillation of wind that blows northeast and then southwest. And when it goes northeast, you get the Indian monsoon. And India gets soaking wet. And it's because of those mountains north of India. Go back, look at the Atlantic Ocean now.
Okay.
Can you see the trade winds?
Yeah.
Right there, from Spain, south past the Azores, off the coast of Africa, and then it goes west and it ends up in the Caribbean.
That's awesome.
But look in between.
Nothing.
There's no wind. And north of that, the winds are blowing toward the east. But in between, you have the doldrums, or the horse latitudes. I believe, I've heard anyway, it's called the horse latitudes because when the Spanish tried to explore that area, there was no wind, they would be calm. They had to throw their horses overboard because they were dying. Now, I don't know if that's true or not, but that is the word on the street in the marine biology world that is why they call it the horse latitudes.
Fascinating.
Oh, there's so much more. Okay, mountains. Do you know what a rain shadow is?
I'm going to assume within the shadow.
You can also zoom on this map too. Oh, yes. But a rain shadow. Okay, where is your wife from?
Oregon.
Have you been there?
Yeah.
Yes. Is it green? Is it wet or dry there? Green or brown?
It's green unless it's in the dry spell in the summertime.
Okay. What part of Oregon is this? I imagine this is close to the coast.
It's in the valley, a couple hours away.
But if you go over the mountains to the west, the coast isn't far away, right?
No, not at all.
Okay.
It's right there.
Have you ever been to Spokane, Washington?
No.
Have you ever been on the east side of the Cascades?
I mean, I've been to Seattle in Washington.
Okay.
That's all.
Seattle is wet, cloudy, moist.
Mm-hmm.
You travel eastward just a couple hours over those mountains, and it is dry and brown.
Mm-hmm.
The difference is the mountains. Because if wind blows across those mountains, it has to go up. And as air goes up, it gets colder. It can't hold as much moisture. The rain falls out. And if it gets over the mountains and comes back down again, it's dry. And this is why Spokane is not a wet area. It's a dry area. It's in the same state. So rain shadows, Israel. The rain shadow in Israel is profoundly important for biblical history, for current weather patterns. Why is the Dead Sea dead? Okay, it's the lowest point on Earth or one of the lowest points, fine, but why doesn't that basin fill up with water like the Black Sea or the Caspian Sea? Why isn't it filled with water? And the answer is the Judean highlands, Israel. I mean, I'm trying to get my brain to skip now, and I'm talking geography and biblical places. I almost said Beersheba, but that's far south, and it's kind of dry in Beersheba. But the other B word, which I just, in Daily Auto Bible today, they were talking about Hebron. That's not even, has to be in the middle of it. Hebron, Jerusalem, that whole entire spine of mountains where the major Israeli settlements are. On the west of them is green. To the east of them is Judean desert. Masada, Jericho. These are desert areas. Now, Jericho was not a desert because they had a spring, but there's nothing green around Jericho. It's dry over there because of the rain shadow of the mountains. So yeah, mountains are very important, and they affect world weather, and they affect regional weather. And the amount of mountains in the world will change global weather patterns. All right, so we're not really predicting weather yet, but we are describing the things that change the weather. Now,
well, and it's like you said from the beginning, the first question was, what is the best predictor? And you can say that tomorrow is going to basically be like it is today.
Yeah.
And then you've branched off from there explaining what are the factors that do make change from week to week and month to month.
You said that along the coast, it seems to be cooler.
Mm-hmm.
Well, it seems to be breezier for two reasons. One reason is that, there aren't any mountains that stop the air from blowing. But there's something else. It's called a sea breeze. This is typical in coastal areas all around the world, especially in the tropics, subtropics, temperate regions, that in the afternoon, a breeze picks up and it blows inland. Doesn't matter where you are, it tends to blow inland. The reason for that is in the afternoon, the land gets warm, and it gets warmer than the water. Therefore, the air starts rising on the land, and it gets replaced with wind coming off of the water. So you have an onshore breeze most afternoons, especially in the summer times, in most of the coastal areas in the world. That also makes thunderstorms. I remember I was in the Georgia marshes with my college roommate, and we were not boogie boarding, not wakeboarding. What was that called? Knee boarding? What was that thing called? I forget.
Wakeboarding?
I guess so. But it's not water skiing because you're kneeling down on the board. And we're in the tidal marshes around Brunswick. And I remember sitting there, I had a turn, he had a turn, his friend had a turn. We went in circles. And I'm sitting on the boat and I'm looking at all these clouds, these thunder clouds. And they're chopped off at the bottom. All of them, they start at exactly the same altitude. And I'm sitting there trying to figure out what was going on. And I'm looking at this one thunder cloud. And I'm after a long time staring at it, I realize it's getting taller and taller and taller. I said, oh, the air. Oh, I got it. And it dawned on me. What happens is warm air wants to rise. Cold air wants to sink. But when the sun shines on land, it only warms up the air near the land. And so you get this blanket of warm air. And above it is cold air that wants to sink. And so they're fighting each other. And eventually an instability will happen. And it'll be like like a hernia. This is one place where the warm air will squeeze up into the cold air and it'll start rushing upwards at that point. And that air is rushing upwards, cooling, condensing, and that's what forms a thunderhead. Oh, that was really neat. And it only happens at a certain altitude because that's the altitude of the dew point. And so really the air is moving underneath there, rushing upwards, but you just can't see it. So sea breezes, atmospheric instability, local weather, sunlight, density of air, cold air versus warm air, mountains, sea currents, Coriolis forces. There's some really interesting things happening here that are affecting our daily enjoyment of the outside. All right, but that's all short term.
Get to the part where the weather carries away all the pollen and we just have clean, fresh air.
Okay, that'll be in January.
Oh.
All right, let's talk about things that are harder to predict. Carbon dioxide, water, methane. These things are called greenhouse gases. They change the transparency of the atmosphere to infrared light. The more of these things that are in the atmosphere, the more heat the atmosphere will hold. This is science. That's not debatable. What are the long-term effects? That's debatable. Fine. But we know that the atmosphere will hold more heat if there's more water, more methane, more carbon dioxide. But methane and carbon dioxide are much stronger greenhouse gases than carbon dioxide. However, carbon dioxide right now is at highest levels since we started measuring it and using atmospheric proxies of old sediment cores or whatever, gas bubbles in Greenland ice cores. We know carbon dioxide now is higher than it's been since mankind has walked on this earth. Now, I think I'm not going to talk about the dinosaur era, which would be pre-flood. I'm not going to talk about the post-flood era because everything's all messed up. But at least for the last couple thousand years, right now, there's more carbon dioxide in the atmosphere than ever before. And that should, because of science, have an effect on the average global temperature. It should go up. Now, whether that's a bad thing or not, that's a great question because, maybe the farmers in central Canada really like it to be a couple degrees warmer in the wintertime or the summertime. Maybe they have a better growing season. More carbon dioxide means plants grow faster. More carbon dioxide means that plants don't need as much water to grow. They don't have to open up the pores in their leaves as much because there's more carbon dioxide to get. So the pores can stay closed longer. They don't need as much water. So maybe deserts will start turning green. But the difficult part of this, and this is where it gets really treacherous, is that you can have some areas of the world get colder if the Earth warms up. Because of changing atmospheric circulation patterns, you might have a desert appear or a rainforest appear if you change the temperature of the Earth. It's not that easy to say, here at my place on the Earth, if we increase atmospheric carbon dioxide, it's going to do X. You don't necessarily know that. And so I remember I graduated with my PhD in 2003, and the computers then, most sophisticated computers in the world that they had, they were not able to model clouds in the atmospheric temperature modeling programs. Clouds are too complicated, global clouds. But computers have gotten an order of magnitude more powerful since then. And so I think they probably have clouds in there by now. And they're getting, more and more fine-scale resolution and more predictive power as far as what the future temperature should be. But there's a giant monkey in the works, and that monkey is called the sun. Because the sun itself is variable. The sun changes intensity over time. The sunspots have a direct impact on Earth's climate. And we just went through a couple of years with 0 sunspots. It's the first time in a couple 100 years. We talked about that in another episode, I'm sure. But we should do an episode on the sun. Right. Okay, put on the list the sun.
Yeah.
Okay, great.
It's happening.
All right, cool. Anyway, so all these crazy things, and they're very hard to predict. But if there were some climate models that predicted cooling and some that predicted warming, I'd say, we're not really sure what's going to happen. But I can't say that. All of the science is pointing toward warming. It's a question of how much and what its effects will be locally. And that's something no one can actually say. There'll be more hurricanes. You don't know that. Because a hurricane is very much dependent upon winds in the upper atmosphere. You got high upper atmosphere winds, they rip hurricanes apart and they destroy them. So will global warming increase or decrease upper atmospheric winds? That's a good question, and that's going to change the prediction of whether or not there should be more hurricanes or not. Okay, so putting that aside, there's another very hard to predict and very long-term thing that affects the weather, and that is variations in Earth's orbit. The axis of the Earth is not always pointing at the North Star. Now, granted, it's going to, supposedly like a 25,000 year period, and I don't think the Earth's been around 25,000 years, but whatever. We've gone through about 1/4 of that cycle so far. So sometimes the North Pole is, let's say, in relation to the sun, sometimes the Earth's axis is more straight up and down, and sometimes it's more at an angle. When it's more straight up and down, that means that the summers and the winters in the northern and southern hemisphere are more similar. When the axis is more at an angle, there's more of an extreme difference. So in the winters are colder, summers are hotter. But when the axis is pointed more up and down compared to the sun, there's not that much of a difference, or there's less of a difference between winter and summer solar values. But the shape of our orbit also changes. Sometimes our orbit is a little more round and sometimes it's a little more elliptical. Now, if the sun was at the center of our orbit, it wouldn't make any difference at all. So if we're closer in at some ports of the year, fine. We're further away at other points of the year, and it all averages out. But that's not true. The Earth is at the focus of our elliptical orbit. And because of that, if we are in a more flat orbit, maybe a more squished, more elliptical, that means, we're closer to the sun at some points in the year, but we spend more time further away from the sun, and we get less sunlight on average. The more round our orbit is, the more sunlight we get on average. Now, granted, that's, tens of thousands of years sort of cycle, but we've already been through 1/4 of that cycle or so, and it affects how much sunlight is striking the Earth. It affects the heat budget of the Earth. And so we're talking about a thousands of years long cycle that we've already been through, and it should be having some effect. And so maybe, you read some ancient account of something and you realize what the weather must have been in that area then, and it's not that way today. Well, maybe it's because of the precession of the equinoxes or the variation in the tilt of the Earth, the axial precession. Don't know. But you want to predict the weather 100 years from now? It's not like we can't know anything.
Right.
But it is like we don't know much. We can apply basic science to the situation. Fine. But there are a lot of things we can't control. There's still some things we don't know. And if you're talking, a major, if an asteroid hits the Earth, that might cool the Earth for a decade because of the particles that will be shoved up into the upper atmosphere are going to reflect the sunlight. Or if we get a massive volcanic eruption, like when Thera blew up on the island of Santorini in the Mediterranean, that would have affected all biblical weather patterns in biblical times. Or when Krakatoa blew up in the South Pacific, that affected global weather patterns for several years. Right now, they're worried about the volcano in Iceland's about to go up. It's doing all these warning signs. Last time a volcano went up in Iceland, they had to shut all air travel down to Europe for a couple of weeks because you can't fly a jet engine through a volcanic plume. The silicates will melt into the engine and jam it up and you'll crash. So the weather is complicated and fun and amazing. And there's big picture things happening that we're dependent upon. And yet, does not the Bible say that summer and winter, rainfall and harvest will never cease?
Right.
This is what God told Noah after the flood. God's in control of the weather. But we know that massive famines have occurred. We know that God's in control of the weather, but we know that massive famines have occurred. We know that locally things have changed, one place versus the other. So the weather does oscillate in very weird and complicated ways. So I have nothing else to say on weather.
Usually people just shoot the breeze about the weather and then they move on. But, you had a lot to say today.
I sure did.
You don't have to talk about the weather the rest of the year. You put in your allotment.
All right.
Thank you so much for joining us on this quest. And if you found this episode interesting in any way, consider sharing it with your friends and family. And if you want to dig deeper into the topic of meteorology or bees or all the host of many other science topics covered on Equinox, you can find the stuff that we've discussed in the show notes on the website. That's available at nightowl.fm/equinox/51. The show notes are also with this episode if you subscribe to the show in an app on your phone. And you should also check out Biblical Genetics, that's Rob's other project. Biblical Genetics is also available on social media and YouTube, where you can watch the videos and join discussions in the comments. And if you want to find me, I'm at JCS Darnell on Twitter, or take a listen to my other podcast, Hi-Fi, which is available at nightowl.fm/hi-fi. Until next time, goodbye, Rob.
Goodbye, Joe.
You've been listening to Equinox. You want to talk about bees for a few minutes?
Yeah, I sure do.
All right.
I think I saw my queen. I think I saw her twice.
You did?
I'm
so jealous.
Well, every day I go and spend at least a couple of minutes, usually a couple times a day, staring at my bees, watching them flying in and out.
Yeah.
And twice I heard a deep and looked down, and a big bee landed and crawled inside. And I said, is that my queen? But see, the queen should never leave unless she was a virgin queen. I don't know what queen I got from the guys we bought the bees from.
Yeah. Oh.
If she was a mated queen, fine. But if she was a virgin bee, she would have had to leave, fly, find some drones, and mate. And she would have done this over several days. And sure enough, I think it was 2 days in a row. It might have been one day in between. About the same time in the afternoon, I think I saw my queen fly into the nest.
Awesome.
So I know you took apart your beehives as we were talking about them.
Yes.
And you think you saw eggs?
Well, yeah. I didn't see a lot of them. There was only brand new comb. It was pure white.
That's fine.
And what we did is we were making our frames where it was rigged as a wooden frame and it's a rectangle running down from top to bottom in, 4 places, there's a wire.
Yes.
And at the top, there's the wax template for about 3 inches going all the way across at the very top.
Yeah.
So what the bees are doing is they're adding their wax honeycomb to the template to hang it down. And one of the pieces, the wax template had been loose. And so when the bees were on there, they caused part of it to rip right off and fall to the bottom of the box. So I took the frame out and I glued it. Well, not glued it. I mean, I heated up the wax over the stove oven.
Like we did the first time.
Just hot enough to make the wax, glue on. But while I was looking at the fresh piece where they've already added wax honeycomb, you could look inside and you could see the little teeny tiny, what looks like yellowy pellets.
Cool.
Yeah.
I've still experimenting with monitoring my bees. And I have a little frustrated with the Arduino unit because I maxed it out and my mass kept on crashing. So I got a new thing. It's called the ESP8266. It was only $3 and it has Wi-Fi built in. And I figured it out. It was hard. I had to get past Amazon. Amazon is awful. I'm not using Amazon Web Services or Internet of Things technology. But I found a website called ThingSpeak. And I figured out how to program this little microprocessor to take a voltage reading from this load cells that I have under my beehive, package them into an ATPS thingy, and send it to this website over the Wi-Fi from my beehive. And in real time, I get to see the mass of my beehive. It's not quite working. It keeps on crashing, and I get negative values all the time. But when it's working, it's like 20 kilograms. Like, hey, this is cool. So right now, I'm also transferring my temperature and humidity sensors, which were working just fine, but I had to run down there and pop the little memory card out and run it up to my computer, copy over the information, and go run down and put it back in the little Arduino before the next save cycle hit. And that was a pain in the neck, and I knew it was going to be a pain in the neck, but now I'm going to take that and I'm going to put them on this Wi-Fi system also. And so I'm just going to be wirelessly broadcasting all these values to this website, which draws graphs for me. I'm so happy.
Nice. Interesting. So now that you've seen the queen and you've been in and out of there, you want to talk a little bit about your sugar water, the styrofoam wall partition?
Oh, yeah, that was a whoops. Okay, 2 things happening here. Bees need help when they have a brand new colony, especially if that colony is set up during a low nectar flow, which is about now. Waiting for the first big honey flow. We may or may not have missed it, but there will definitely be one probably in August when they start really packing on honey.
Yeah.
But right now, it's a little slim pickings, and it's a new threatened colony, and they need food. And so we have a sugar water feeder, which we made with a, what's it called? A bell jar, one of those canning jars. And we just poked little teeny holes in the lid and flip it upside down into this wood box that we built, and bees can crawl into it, lick the bottom side of the lid, and crawl out again. I mean, I fill mine up at least once a day. It's a quart jar. I mean, twice a day usually.
I'm checking it every day. Every time I check it, it's empty.
Yeah, they suck it dry pretty quick. And so I'm trying not to let it go dry because I don't want them to panic. I don't want them to start thinking they have to go somewhere else to find a lot of food. I'm also worried about other bees finding it, though, because you're not supposed to feed open like this. And our thing is exposed outside. Other bees could just fly up to it. And if they find out nectar, they're like, hey, what's in that little hole right there? Oh, there's a whole bunch of other bees in here. And a strong colony could sweep in and overwhelm our new colonies, take all their food, and just fly away with it. And so I actually took mine and I turned it and I stuck it on my beehive to block up one of the holes. But it means that you can only get to the sugar water from inside the beehive. So for yours, keep on looking, because those 2 videos I sent you, that what robbing looks like, look at your bees and see if they're happy and doing what normal bees do, or if they look like someone else is coming in and robbing them. Because you can't tell bees are bees, right? They look kind of the same from one colony to the next. They just smell different, but I'm not going to smell a bee. So, yeah, pay attention to that. But okay, the styrofoam debacle. Audience, Joe and I made a big mistake. I did it to Joe. My fault.
Right. Well, speak for yourself. You don't know my story.
No, it's my fault.
No. I mean, your styrofoam situation is not the same as mine.
This is true. But I wanted to build a partition in this beehive to split it in half. So we have the opportunity of having 2 colonies at once, taking one strong colony and splitting it into 2, or finding a swarm and putting it in there. Maybe a wild swarm could move in. All different options here. Plus, the bees didn't need a space that big when they first starting out. I think they'll fill it up eventually, but they didn't need it right away. And so I built this wood partition to fit down the middle, but I couldn't quite get it exactly the right size. And so I gave up, and I built one. I brought it over to Joe's, and it was loose. It's like, oh man, I didn't cut it big enough. Oh no. And it was one piece of oak too. So it's too late. I already cut the piece of oak. Didn't know what to do. And so Joe and I both put a piece of styrofoam into the beehive, just shoved it down. It was only like an inch thick or 3/4 of an inch thick. Cut it to about the right size and just shoved it down there tight so the bees couldn't get from one side of the hive to the other.
And in theory, it would work flawlessly. It looks really good. Well, your story, though, is totally different from mine. It's so weird to me.
Yeah, the beetle traps that I built, the little mason jars on the bottom of the hive with 1/8 inch holes drilled in the top, which a beetle can fit through, but a bee won't. I opened one up and I looked at it and I was like, was that powdered sugar? What is that? And I stuck my finger in it. I'm like, wait a minute. It is powderized styrofoam. It's like, oh no, the bees are eating the styrofoam.
Right.
I opened up the lid and sure enough, they had scraped away a good portion of the front side of the styrofoam. The other stuff, though, it was yellowed. They were coating it with propolis. But about half of it, they had eaten through it, and in one edge of it, they had completely eaten through, and they were on the other side of the hive, and the part that I didn't want them yet. And so, oh no. Well, what I figured out, though, was I had that board that was a little too small.
Yeah.
I wrapped it with a piece of weather stripping.
Oh, okay.
And shoved it down there really tight. So I still have a board there. But I just got in the mail some queen excluders.
Queen excluders.
It's a metal or plastic, and it has slits in it that are as wide as a honeybee, but smaller than the queen. And so the workers will crawl through it, but the queen can't. And so if we put this as the partition, then the queen can't get to the other side of the hive. The only thing you can get on the other side of the hive is honey. And so maybe you can leave the first half of the hive, for that's the colony's winter stores, and anything they pack on the other side could be ours or something like that.
Right.
And so, but I also have to make it such that it's adjustable. And so I've got in my mind a design where the queen excluder has a wooden frame, but 2 of the corners have a wing nut on a slot, and then bolt is on a slot, so I can expand it up and down and left and right just a little bit to make sure it fits in there and it's square to the sides. Because what I don't want is a little gap that a bee can't get through and a beetle can, because then the beetles will just hide in there.
Ugh.
I want it flush up against the walls, so it's got to be exactly right. But wood is tough because, I built this out of wood. That means it's not exactly 90 degrees anywhere. And wood swells and contracts with moisture and temperature.
Right.
So it's really hard to build a wooden partition, but I think I got it now. And so pretty soon I'm going to bring over to you a new partition.
Yeah.
Now, they didn't eat your styrofoam.
No, and it's so weird. From the look on your picture, there's that big gnawed picture of the styrofoam. It looks like a crater in the styrofoam. And then when I looked in my beetle traps, I did see the little teeny bits of some styrofoam. It resembles freshly shaved Parmesan.
Yeah.
When I checked my styrofoam wall, there's just a little bit of nibbling, but next to nothing. It's still there more than a week later.
I'm guessing that when I put my partition down in there was a little gap in that one spot. And the bees are like, hey, there's stuff on the other side. There's an open cavity over there. So they just made the hole bigger.
Maybe.
And they just kept making it bigger and bigger and bigger and bigger and bigger because they're like, hey, we got a whole nother half of a hive we're going to fill up.
Yeah. They saw the opportunity on the other side of the tunnel.
Something else I did. After my bees had been in there for 7 days, I set up a video camera and I recorded as I opened up the hive, took off the burlap cover, and I pulled each frame out to examine them because I just needed to know, had they been robbed? Are they doing okay? How are they looking? And sure enough, about 5 or 6 of the frames had 1/3 to 1/2 of wax comb drawn on it. and the middle ones had a bunch of what looked like honey. But the problem is I got a bunch of cross combing where they're connecting one frame to the next.
Really? Huh.
Arrgh! Bees are supposed to go this way, and they're going at right angles to where I wanted them to be. So I think next year, instead of using this wax strip, I'm actually going to use a plastic foundation. It's a plastic honeycomb.
Yeah.
Now, I don't necessarily want to go all the way to the bottom because I want them to build the size of the cell that they want to build. I don't want to force them to build this evolutionary informed size for a cell. But I think I want this plastic stuff because it's not going to bend like the beeswax that we put in there.
Yeah, that makes sense.
And that's going to be more than just an inch or two. It's going to be like half the frame or something like that.
Even if we did use more of the wax template, they come in a much larger box, and we were cutting them down into shorter strips.
I was trying to save money, man.
Of course, I would too. But if we did just use larger strips, then it may work as well that way.
As long as they stay stuck to the wire and they don't bend. And so, I found a piece on the ground that had broken off. I don't know if the weight of the bees pulled it off, or I think if it's a loose spot, the bees might actually pull the loose thing. Because they don't want to build
on something rickety
or where we want them to build it. If you look at wild beehives, they tend to be in nice orderly rows, but then they do weird things and they make H's and T's and galleries and tunnels and things like that.
Oh, that's true. Yeah.
They're the masters at airflow.
My wife and I were looking at an example that as a cross section, it actually looked like a heart. It's really cool.
Cool. And some of them look like mazes.
Yeah.
So there's always a path through it for air and for bees, but it's not as neat and orderly as we like it. But we want it neat and orderly so we can harvest the honey. And they're like, I don't care what you think.
Yeah. Maybe your bees are different and more, I don't know, like creative? Is that what the bees are thinking? Because when I checked them yesterday, so far, so good. Knock on wood, they're still making their honeycomb in the correct pattern.
Cool.
But I know there's a lot more to go.
I'm not planning on opening this up again for a good long while, but we'll see.
I'm only checking in at about maybe once a week to just make sure that...
Well, you only had them a week.
And I'm only want to glance at like 2 or 3 frames to just see, are y'all doing okay? You didn't die off in a week?
Oh, we have another option.
Mm-hmm.
You can get an endoscope that can connect to your phone.
Ooh.
And we drilled holes in the bottom of these beehives for those beetle traps.
Right.
And most of these endoscopes you get online, they have a light. And it's like a 6-foot long thing. And so you can shove it up there and poke around a little bit and you can look at things. I don't know what you can see because I haven't ever actually tried it. Curious to try. I want to know if this works.
Interesting.
Because I need to know how the bees are doing. They need to be manipulated sometimes, but I want to take as much of a hands-off approach as possible because they don't want me messing their hive up, man. They're happy.
I have noticed when I did open them up and I was checking on them to get the queen excluder, well, not the excluder, but her queen box out of the bottom.
Yeah.
That when I lifted up the frames and there were many bees hanging on it, they were pretty chill and they noticed that the light had moved and maybe they were feeling the breeze at first. No big deal. But when I wanted to put the frame back down into the box and not crush bees one frame against another,
yes,
I took my brush and I brushed them away. And that triggered them. They were totally fine with me. They were totally fine with opening the box. No big deal. Even touching them with my finger. But if I brushed them, they went, whoa, and they came at me.
Yep. One thing I do is if I have to put something back, like every time I put the sugar water back or a frame, same thing, you kind of put it in, but you don't shove it down. You kind of like the sugar water, I'll put it down, lift it up, put it down, lift it up, put it down, lift it up. Then all the bees get out of there, the pinch spot. They won't get there, and then I can put it down, there's no bee there. If I just put it in, I'm going to crush somebody. And do the same thing with the frames. I put it down, and I don't push it up against the other frame quickly. I kind of push it and pull it away, push it and pull it away. I kind of like bonk the bees a little bit, and they're like, hey, I don't want to get bonked. And they move out of the way, and then you can push it over. But there's so much I still don't know. I'm terrified that I'm going to lose my colony. And I did all this work building this beehive and doing all this electronic monitoring, and then they're just going to die.
You're just going to have to buy another bunch of bees.
Yeah, I can't do
another
it
colony.
this summer.
For a year.
Oh, that'd be terrible. But there's a high risk here. We only have one hive, and I've been doing it for a couple of years, and you haven't been, but I consider myself a newbie at this. I'm not an expert in this in any way.
I just ordered a book for beekeeping for beginners.
I'm very wise. Very, very wise. So our rate of success here is actually pretty low because we're brand new at this. Not because we have one hive. Right. It's because we're like, that styrofoam thing, that could have been a giant mistake. What if that was toxic? Yeah. Or the bee feeding thing.
Or painting the outside of my bee box, yeah.
It's a great color, yeah, but hopefully it's not toxic, but I don't think it would be.
I did Google it and I didn't see any scary stories, scare stories of latex paint causing a bee problem.
I wouldn't think so either. But there's all sorts of little things like that. I mean, what if the neighbor sprays a bunch of pesticides on his lawn?
Right.
Right when our bees are harvesting crops from his lawn or his hedges or something. Now, granted, honestly and truly, I don't think that's going to be a problem because people don't really spray pesticides. They might put 7 down on an ant mound, but it's not like they're going around with a plane and spraying from the air on a soybean field or something like that. So I don't think that's going to happen, but I'm still worried about neighbors because yeah.
Well, we'll have to wait and see. We're bound to have more interesting stories as the months unfold and we finally get to the honey harvest in August. I can't wait.
I can't wait either.